All right, so if we're talking about the mole concept, this is starting chapter 6. All right, so the mole concept, are we there? Give me a thumbs up if you guys are there. Or just say you're there in the chat. Okay, cool. All right, so when we talk about the mole concept, all the mole concept tells us is that we have these really tiny particles, and you know, when we talk about particles, jeez, she does this every day. And when we talk about these particles, we group them. We group them because they're so tiny, you know, we can't see the particles. Remember I said even in a strand of hair, we got millions and billions of particles or atoms in one strand of hair. So instead of trying to count the atoms, we end up grouping them into groups called moles. And all a mole is what chemists use as a dozen. It's like a chemist's dozen, which essentially means we all know what a dozen stands for. A dozen is 12. So when we say we have a dozen bananas, that just means we have 12 bananas. Or if we have a dozen calculators, we have 12 calculators. Or a dozen students, that means I have 12 students. So when we talk about a mole, the numerical number for the word mole, 1 mole is equal to 6.022 times 10 to the power of 23. And we say that equals to the however many particles we have. So this is a really big number. We got a lot of zeros here. It's a huge number. And we call this number Avogadro's number. So we say Avogadro, it's not avocado, it's just Avogadro with a G. Now what we say about the mole, the way we get this number, we say that the mole, the numerical value of the mole is defined as being equal to the number of atoms in exactly 12 grams of pure carbon 12. So this number right here, this 6.022 times 10 to the power of 23 is equal to if I had 12 grams of carbon 12. That's how many particles or how many atoms there would be in 12 grams of carbon 12. So when we talk about a mole, remember the particles, a particle is either considered an atom. Sometimes the particles are molecules, depending on what the compound is. And sometimes the particles are even called ions if they have a charge on them. So if I say I have 1 mole of calcium, I abbreviate mole with MOL, and I can say 1 mole of calcium is equal to 6.022 times 10 to the power 23 calcium atoms. And that's just because calcium is just an atomic element, And we'd say its particle is called an atom. Let's say this calcium atom loses 2 electrons, and I now have calcium 2+ like this. 1 mole of that, the way I'd write that out, it's still equal to this number, but I'd say now I have calcium ions. If I said I had 1 mole of water, water is a molecular compound. And the way we describe it, since this is a compound, it's not just a single atom or a single element, we'd say that I have this many molecules of water or water molecules. So that's what I'm saying, that a particle can be an atom, molecule, or ion. It just depends on what we're talking about. If I'm talking about just a single element, I call it an atom. If I'm talking about anything with a charge, I call it an ion. And if I'm talking about a compound like water, I call it a molecule. If it's an ionic compound, we call them formula units. So I could write that out as well. Let's say I have 1 mole of calcium oxide. Calcium oxide is a ionic compound, so its base unit is called formula units. Versus molecules. So when we talk about Avogadro's number, or even this mole concept here, anytime we have something equal to each other, we can use it as a conversion. Just like we did in chapter 2, just like I'm saying, if 1 foot equals 12 inches, that's a conversion that I can use to convert from feet to inches. So if I know 1 mole of anything equals this many of them, that means that's a conversion from moles to atoms, or a conversion from moles to ions, or a conversion of moles to molecules. So let me set up an example to show you what I mean. It says, how many, this is an example, how many particles are in each of the following? So the first one is saying if I have 3.4 moles of copper, and then B says if I have 1.5 times 10 to the power of 2, let's say I have cobalt ions. And this should say, moles of cobalt ions. So the way I'd set this up is I'd say, okay, I'm starting off with copper. I want to convert it to a particle. The particle would be an atom. So remember, a particle is either going to be an atom, molecule, or ions. In this case, it's going to be an atom because I have a neutral element. So if I set this up, it's essentially saying I can use this conversion that says 1 mole of anything is going to be equal to this number. And that's how many particles you have. So if I set it up, I start off with 3.4 moles of copper. My conversion says I want to get rid of moles of copper first. So I'm going to write it in the denominator, moles of copper. And then I want to convert to atoms of copper. So I'm going to say copper atoms at the top. And then I literally just plug in the conversion. 1 mole equals this number. So in this case, you can always put the 1 in front of the mole when you use Avogadro's number. 1 mole equals 6.022 times 10 to the power of 23. Now we have to practice putting this in our calculator because we got to remember how to use the EE button so we make sure we get the same answer. So let's pull out our calculators. And let's try to do this. All right, so when we pull out our calculators, we're going to end up getting 3.4, open parentheses. We're going to say 6.022. And remember when we say times 10 to a power, we're going to hit the EE button. So we're going to hit E, and I'm going to say 23. And then divided by 1. And we should get this number in our calculator. How many sig figs do we need? Okay, you gotta hit
2 only.
2.
Okay, so we need 2 sig figs because we started with 2 sig figs. So our final answer should say 1, 2. We look to the right, we keep that as a 0 because it's a 4, times 10 to the power 24. So the answer for this one is 2.0 times 10 to the power of 24, and this is copper atoms.
We could also do 2.0 E24, right?
Yep, in the homework, that's how you'd have to write it. All right. So,
I'm sorry, are you going to say to convert to atoms? Like, is that a given, or how do you know what to convert to?
you just know it's an atom because that's the base unit of any element. We call them atoms. We call this an ion because it has a charge on it. But if it's just copper, we say it's an atom. If it's a compound, we say it's a molecule.
Okay.
And sometimes
If there is a formula unit.
if it's an ionic compound. So this is a metal and a non-metal. These are 2 non-metals. All right, so let's do the next one.
We don't write like suppose CaO formula unit.
Say it again.
After solving the problem, we don't need to write a CaO formula unit.
Yeah, but we started off with just copper. We didn't start off with formula units. We didn't start off with CaO. Which one are you talking about here or are you talking about here?
On the above one, CaO.
Yeah, this is saying I was given as an example that if you have an ionic compound, which is a metal, which is calcium is a metal, oxygen is a non-metal, the way you call ionic compounds, we call them formula units. Molecular compounds, we call them molecules. So if we do B, this was A, if we go ahead and do B, we have to set it up the same way. So B is now saying, if I have 1.5 times 10 to the power of 2, and this is moles of cobalt ions, when I go ahead to convert this, once again, I want to get rid of moles. So I got to write moles at the bottom. And I'm going to write moles of cobalt ions. And at the top, I'm going to write, I'm trying to convert it to just cobalt ions. So I'm going to say, once again, the 1's going to go where the mole is. And anytime you have moles to ions, the conversion is the 6.022 times 10 to the power of 23. So let's see if we can put this in our calculator and get the same answer.
Make them like 9.0 into 10 to the power 25.
Okay, so we get that we need 2 sig figs. So with 2 sig figs, we put this in our calculator. We're going to get 9.0 times 10 to the power of 25. And this is going to give us cobalt ions. And, or you can say E25. And guys, remember when you're putting in your calculator, let me see this calculator. Remember when you're putting it in the calculator, a lot of times you guys will get something like this. You got to remember to look over here and don't forget about the times 10 to the 25. You'll just write 9.0 down. You got to say 9.0 times 10 to the 25. All right, let's do another one where we have to do from particles to moles. So let's say,
I'm sorry, I have a quick question. When we put it into the, for the homework or quizzes, do we want to write the cobalt ions on there also?
no, we're not writing units.
Okay.
All right, so it says a silver ring contains 1.1 times 10 to the power of 22 silver atoms. All right. How many moles of silver are in the ring? So it's literally saying we have a ring that we put on our finger. It's a silver ring. It's made out of all silver. It wants to know how many moles there are if you have this many atoms of silver in your ring. So we set it up by saying, if I start off with 1.1 times 10 to the power of 22, and this is silver, silver is Ag. I start off with silver atoms. I now want to convert to moles of silver. So what unit goes at the bottom, guys?
Mole.
What unit goes at the bottom? It's just like all the conversions we did before.
Atoms.
All right, if we start off with silver atoms, we need silver atoms at the bottom because that's what we're trying to get rid of. Silver atoms. So that means what unit goes to the top?
Silver mold.
Exactly. So silver moles or moles of silver, either way you want to write it. Now, where does my 1 go, guys?
Denominator?
On your moles in the numerator?
They're going to go at the top because remember, we're just literally putting the 1 wherever we see the mole. It's saying 1 mole is equal to this number.
Okay.
In this case, we can say 1 mole equals 6.022 times 10 to the power of 23. I got silver atoms at the top. I got silver atoms at the bottom. They cancel each other out. And I'm left with units of just moles. So let's see if we can put this number, this calculation in our calculator and get the same answer.
It's a 0.0 with no sig peak.
You got 0.0. Probably need to move your decimal over some more. You need to change your mode, not your mode, your I don't know which calculator you have. Remember, if you have the float, you need
1.8, I think 1.8.
all right. So when we get this in our calculator, what did you guys get?
1.8.
0.018.
Okay, yep, so we end up getting 0.018, and this is gonna be moles of silver, or silver moles. Or we could say 1.8 times 10 to the negative 2. Remember, we can just say 1.8 times 10 to the negative 2 moles of silver. These mean the same thing.
Oh, okay, okay. Okay, I see.
All right, so let's do another one. Let's see. All right, so let's do another one. Let's say, for instance, I want to now use a compound like water. And the question just says convert. 5.92 moles of water to molecules of water. Let's see if you guys can do this one. Okay, let's talk this out. If I start off with 5.92 moles, and this is of water, this is what I'm given, and I want to convert it to molecules of water. What goes at the bottom, guys?
Molecules H2O, MOL H2O.
So moles. So although these are similar words, they do not mean the same thing. So moles is different than molecules. So at the bottom here should go moles of H2O. And then what goes at the top?
Molecules
Molecules is going to go at the top
H2O.
of water.
because that's what we're looking for. Where does my one go?
Down 1 mole.
On the denominator.
Yep, 1 mole equals 6.022 times 10 to the 23 molecules. So in this case, how many sig figs should my answer have?
3.
What did you guys get for an answer?
3.57 into the 10 to the power 24.
Say it again for me.
3.57.
3.57 into 10 to the power 24.
Yeah, okay.
And this is molecules of H2O.
So if I would put MOLH2O, you would mark it wrong, right?
They're two different things. Moles is saying, it's like the word dozen. You know, a dozen means 12. Moles literally means this number.
Okay.
Big number. Or like a ton. You know how like if you say a ton what means 2,000? A mole is the same thing. So 1 mole equals this number of anything.
Okay.
I have a mole of people, and a mole of people is saying I have this many people. And we don't ever say that because that's a lot of people. What we end up saying is like we have a mole of particles or a mole of atoms because we have to get that many atoms together to actually like see them. Does that make sense?
Yes, that makes sense.
Okay. All right, so that's the mole concept. I'll talk about one other thing and then I'll wrap up for today. So we also have what is known as the molar mass. So just remember, anytime you want to go back and forth between moles and particles, you just got to use this number, this conversion. 1 mole of anything equals this many atoms, ions, molecules, and formulas. So if it says convert to moles or convert to atoms, you got to use Avogadro's number. Now, sometimes, not even sometimes, a lot of times, we want to convert from mass to moles because in reality, we're not going to sit around and count the particles. We're not going to sit around and count atoms. What we're going to do is weigh out how many atoms, weigh out the mass of it. And if we know the mass, we can then convert our mass to moles and figure out how many particles we have. So what this means is saying, I have a concept known as the molar mass. And all the molar mass is saying is it's essentially the same number as the formula mass. And it basically is saying it's the mass of 1 mole of an element. So for example, right before the break, we talked about the formula mass of water. Remember we said we broke it down to 2 times the mass of water plus 1 times the mass of oxygen. We ended up getting 18.02, and I said you guys can write AMU because it stands for atomic mass units, but I'm going to tell you something different in about 20 minutes. This is the something different. Now we're going to say the molar mass is essentially the same number as the formula mass. So not only is the formula mass 18.02, the molar mass, we say that there are 18.02 grams for every 1 mole of water. And we say grams per mole are our units, which essentially is saying 1 mole of water is equal to 18.02 grams of water. And once again, if we have an equal sign, we can set it up as a conversion. So anytime I want to go from grams of a substance to moles, I have to use what we now call the molar mass, but essentially it's just the formula mass. So let's do an example that says, calculate the number of moles of sulfur in 57.8 grams of sulfur. Now in this case, our given number is 57.8 grams of sulfur. So since we start off with grams of sulfur, what unit needs to go at the bottom? What unit needs to go at the bottom of the first parentheses?
Grams of sulfur.
Grams of sulfur, great. And the unit that needs to go at the top, since we're trying to convert it to moles, it's gonna be moles of sulfur. And in this case, once again, we can always put the 1 where the mole is. So the mole is on top. I'm gonna put the 1 up here, and I'm gonna say it's equal to the mass in grams. So I'd have to pull out the periodic table. I look at my periodic table. Where is my periodic table? Got it. Look at my periodic table for sulfur. I go to S, sulfur, if I round to 2 decimal places, 32.07. So I'm gonna say it's equal to 32.07 grams. I put that in my calculator. I'm gonna need 3 sig figs. 57.8 divided by 32.07. I end up getting 1.80 moles of sulfur.
Why do we need just 2 sig figs?
Sorry, we need 3. 1, 2, 3. 1, 2, 3. That 0 is significant. Remember, there's a
Yeah, I
decimal.
see you write it, but then you said 2. No, it's-
I'm sorry, that was a mistake on my part. All right, let's do one more example and then we'll wrap up for the day. Now this example says, let's just go ahead and convert. Let's say, what is the mass in grams of 0.94 moles of sodium bicarbonate? Sodium bicarbonate is NaHCO3. The formula looks like this. And I'll just write it here, sodium bicarbonate. And all sodium bicarbonate is baking soda. Like literally, if you look on the box of baking soda, it says sodium bicarbonate. So let's see now, I'm starting off with moles and I want to convert it to grams. Let's see if I can convert this to grams. Now this one's a little different because remember, anytime we're going from grams to moles, we have to have the molar mass. So we'd have to spend a second to calculate what the molar mass of sodium bicarbonate is first, so we could write it out in grams. So we got to say, okay, let's go figure out the mass of sodium bicarbonate. And we can say that that in grams is equal to 1 mole. And then we can set up our conversion. So meaning, if I start off with this many moles, you guys tell me, so I'm going to put sodium bicarbonate. Let's talk about what unit goes at the bottom.
The moles.
The moles of sodium bicarbonate go at the bottom. And then what unit goes at the top?
The grams.
The grams do. So grams of sodium bicarbonate go at the top. And we have to figure out what they are. So where's my 1 go?
Bottom.
The 1 goes in front of the mole. We get that part, but we have to figure out how many grams this is. And the way we figure out the grams is we have to add all of this up. So we have to say sodium, the mass of sodium plus the mass of hydrogen plus the mass of carbon plus 3 times the mass of oxygen. So when we look on our periodic table, we say sodium is technically 22.99 plus hydrogen is 1.01 plus carbon is 12.01 plus 3 times oxygen, which is 16.00. So we have to add all that up first and get a number.
The 8401.01.
So you ended up getting 84.01. Let me see. 12.01 plus 3 times 16. Yep, 84.01. So this technically is equal to 84.01 grams. So essentially it would look like this. So of NaHCO3, 84.01 grams of NaHCO3 over 1 mole of it. I only wrote it out like this so you guys can see where I get the 84.01 from. And we multiply them together. And I end up getting with 2 sig figs, looks like 79. 79 grams of sodium bicarbonate. Okay. Yeah, Adriana, you have a question?
Yes. For the hydrogen, to find the mass, I thought we were supposed to multiply by 2.
Do we have 2 hydrogens in sodium bicarbonate? Oh, that's when hydrogen's by itself. Okay, I get what your question is.
Right, because it automatically has 2, no?
When it's by itself. So if I say it in a compound, this is what it is. If I'm saying what's the mass of just hydrogen gas, that's when we multiply by 2. So basically, hydrogen in a lot of compounds. So for instance, like HCl, it's only 1 hydrogen. Or like HBr or HNO3, that's only 1 hydrogen. All of these are only 1 hydrogens. But if I say, okay, what's the mass of just hydrogen gas? It's always going to be H2.
Oh, okay. 21. Okay, thank you.
It's already in the compound, so it's telling you how many hydrogens you have.
Okay.
All right, guys, any other questions? So this is basically, we talked about Avogadro's number. I'm just going to sum up really quickly. Avogadro's number says I can convert 1 mole to the amount of particles. Says I can use 1 mole equals 6.022 times 10 to the power of 23, and that's a particle. And a particle is either going to be an atom, a molecule, ion, and I'll even say formula units. These are all the different types of particles. But if I'm using the molar mass says I have 1 mole is equal to the mass of that substance in grams. And it has units of grams per mole. So this is basically the formula mass in grams. So 1 mole is equal to formula mass in grams, and the way we write it out is grams per mole is the unit. So anytime I want to go back and forth from moles to grams, I got to use the molar mass, just like I did on this last question. I use the molar mass. 1 mole is equal to this many grams, or 1 mole is equal to this many grams. I have to use the molar mass. Anytime I want to go back and forth between moles and atoms, I have to use Avogadro's number. Or if I want to go back and forth between moles and molecules or any type of particle, I have to use Avogadro's number. All right, do I have any questions? Okay, well, we'll pick back up on this tomorrow. I feel like I gave you guys a lot today. We'll pick back up on this tomorrow, and I'll post the worksheet that we'll need. I've already posted the mole concept worksheet under chapter 6, and we still got to talk about a few other things with the mole. But all right, if I don't have any questions, that's the end of the lecture today, and I'll see you guys tomorrow.
Thank you. Have a good evening.
Thank you. Have a good one.
Bye, guys.
Bye, everybody.
Bye-bye,
Thank
everybody.
you.
Thank you.
Bye.
Yeah, from the